Hi, this is Sangeetha, Assistant Professor EC Department, SNS College of Engineering. Today I am going to discuss about sensors and actuators which was used in IoT. So let us start with the sensor and actuator, the introduction of sensor and actuator. So first, what is a sensor? A sensor is a device that senses, that listens to the physical equipment and tells what happens. So each sensor is able to listen the environment and tells you what happened. So it listens the environment to a specific input that can be light, heat, motion, pressure or moisture, anything. So any one of the input of the environmental phenomena. And next about the actuator. Actuator is a device that converts electrical energy into movement. It could be a valve or a motor, example a display, a LED, a loudspeaker. So next we will discuss about the different types of sensors used in IoT. The first one is humidity sensor. The number is DHT22. The DHT22 is a digital humidity and temperature sensor that uses a capacitive humidity sensor and a thermistor to measure the relative humidity and the temperature of the environment. It has a high accuracy and can operate over a wide range of temperature and humidities. The technical details are the power is up to 3 to 5 volt, the maximum current 2.5 milliamps and humidity 0 to 100%, 2.5% accuracy, temperature 40 to 80 degrees Celsius. And next about this is the connection of humidity sensor with Arduino board. And next about the temperature sensor. The number of temperature sensor is LM35 and it is an analog temperature sensor and a precision integrated circuit temperature device with an output voltage. It is linearly proportional to the centigrade temperature. It does not require any external calibration or trimming to provide typical accuracies. So the temperature of the environment, it measures the temperature of the environment and produces an output voltage proportional to the temperature. So the technical details are, it is calibrated directly in Celsius, it is linear and it measures the accuracy at 25 degrees Celsius and suitable for remote applications. And this is the connection of a temperature sensor with Arduino board. The next one is water sensor, water detector sensor. So water detector sensors are used to detect the presence of water or other liquids. So water detector sensor brick is designed for water detection, which can be used in sensing rainfall, water level and even liquid leakage. So then typically use a conductive sensor that detects the conductivity of the liquid and produces an output signal when the conductivity exceeds a certain threshold. And these are the some technical details, that is power is about 3 to 5 volt, maximum current 2.5 milliamps and the temperature is 40 to 80 degrees Celsius. This is the connection of water sensor with the Arduino board. And next about PIR sensor, that is passive infrared sensor, is a motion sensor. It allows to sense the motion. They are used to detect whether a human has moved in or out of the sensor's range. They are commonly found in appliances and gadgets used at home or for business. They are often referred to as PIR sensor, passive infrared or pyroelectric or IR motion sensor. So it's commonly used in security system and automatic lighting systems and other applications where motion detection is required. And the next is about the connection of PIR sensor with Arduino board. And the last one is ultrasonic sensor, that is HCSR04 ultrasonic sensor. It uses a sonar to determine the distance of the objects, just like the bats. So ultrasonic sensors use sound waves to detect the presence of an object or measure the distance of the object. They typically emit at high frequency sound wave and measure the time it takes for the sound to bounce back, that is echo, after hitting an object. So the operation is not affected by the sunlight or black material, although acoustically. Soft materials like cloth can be difficult to detect. It comes complete with ultrasonic transmitter and receiver module. The technical details are power supply plus 5 volt DC, quiescent current less than 2 milliamps and working current 15 milliamps, effective angle 15 degree, less than 15 degree, and resolution is 0.3 centimeter, measuring angle 30 degree. This is the connection of connection of Arduino with ultrasonic sensor. And next about motors. So there are three types of motors used in that is IoT, that is it can be connected with Arduino, DC motor, servo motor and stepper motor. So the DC motor, that is DC direct current motor, is simple electric motor that converts electrical energy into mechanical energy. It consists of a stator, fixed point, and a rotor, rotating point that are separated by an air gap, and the rotor contains a set of coils that are energized by the DC power source, causing the rotor to rotate. So the DC motors are commonly used in fans, pumps and other low power applications. The components required Arduino to connect with the Arduino is Arduino Uno board and transistor, DC motor and one diode, and 270 ohm resistor is required to connect the DC motor with the Arduino. So this is the connection details of Arduino with the DC motor. And next we will see about next we will move on to servo motor. Servo motor is a small device that has an output shaft. So it is a type of DC motor that is designed to provide precise control over the position, speed and torque of the motor. It consists of a DC motor and additionally it has a feedback sensor and a control circuit that adjusts the position of the motor based on the feedback from the sensor. So servo motors are commonly used in robotics and RC vehicles and other applications that require precise control over motion. So using pulse code modulation, the control wire is used to communicate the angle. The angle is determined by the duration of a pulse that is applied to the control wire. This is called pulse modulation. So the servo motor has some control circuits and a potentiometer connected to the output. So this part allows the control circuitry to monitor the current angle of the servo motor. So this is the working principle of servo motor. And the next we will move on to stepper motor. A stepper motor is a type of motor that moves in a small precise steps, making it ideal for application that require accurate positioning. It consists of a rotor with a set of teeth and a stator with a set of coils that are energized in a specific sequence to rotate the rotor in a small steps. So stepper motors are commonly used in CNC machines and 3D printers and other applications. So the stepper motors therefore are manufactured with steps per revolution of 12, 24, 72, 144, 180 and 200. So resulting in stepping angles 30 degree, 15 degree, 5 degree, 2.5 and 2. These are the different angles. So the stepper motor can be controlled with or without feedback. So this is the working condition of stepper motor. So each type of motor has its own strength and weakness, and the choice of the motor depends on the specific requirements of the application. For example, DC motors are simple and inexpensive but lack precise control, while servo motors are more expensive but offer greater precision and control. Stepper motors offer the highest precision and control but may be more expensive and require more complex control circuit. So thank you.